So there are four basic derivative rules that you have to know for the AP exam. The first is the power rule. You can see it here. This is often applied to polynomial functions. So anything like x cubed, x to the fourth, anything like that. This is a really common rule that you're going to have to know and be able to use. I did put a little mnemonic here that may help you memorize it. It's just bring it down -1. So an example of that would be like x to the fourth. When you take the derivative of this, you're going to bring the exponent down, and then you're going to subtract 1 from the exponent. So it would be like that. Next rule you'll have to know is the product rule. This can be used in a lot of different applications. Again, I put a mnemonic device here. This is how I have it memorized. So basically in my head, whenever I'm doing the product rule, I do first times derivative of second plus second times derivative of first. All right, moving on to the quotient rule below it. This is another rule that is going to be applied in many different scenarios. You can, of course, either just memorize it as it's written here. I like to kind of, again, just say a little bit of a song in my head. So I say low d high minus high d low, and then just over low squared. That part doesn't really rhyme, but it just kind of works somehow. So again, just low d high minus high d low over low squared. And then the chain rule, I don't really have a mnemonic device for this one. Really how I memorize the chain rule is I just imagine taking the derivative and then multiplying by the derivative of what's on the inside. I also tend to use u sub with the chain rule just because I find it easiest. Okay, let's go ahead and move on. Okay, so for number 1, it tells us that f of x equals sine of 3x, and we're asked to find the derivative. So first thing I have to know to have success here is I have to know that the derivative of sine is cosine. So I have to have my trig derivatives memorized. Second, I have to be able to identify this as a chain rule problem. So I have to notice that this is a composite function, which is just a function within another outer function. So because I know I'm going to be using chain rule here, I prefer to use u sub. So first thing I'm going to do is I'm going to identify u as 3x, and then I'm going to get u prime just by taking the derivative of that, which is just 3 using the power rule. Now, I'm going to go ahead and rewrite f in terms of u. So I'm going to write f equals sine of u. Now I'm going to get f prime by taking the derivative of that. So derivative of sine is cosine of u. And now I have to multiply by u prime because of the chain rule. Now I'm going to go ahead and plug all of this back in. So I'm going to get f prime equals cosine of 3x times 3, or just cleaned up and rewritten, it would be 3 cosine of 3x, which is answer choice B. Okay, so for number 2, again, we have to know the derivative. Our log derivative of e to the x is just e to the x. And again, I have to identify this as a composite function where I'm going to be using the chain rule. So let's go ahead and use u sub once again. So my u is going to equal 2x to the third, which makes my du, or my u prime, equal to 6x squared. Now I'm going to rewrite g in terms of u, so that would just be e to the u. Now I'm going to take the derivative of g using the chain rule. So I'm going to get g prime equals e to the u times u prime. Now I'm going to go ahead and just plug back in. This would give me e to the 2x cubed times 6x squared. And again, just cleaning this up and simplifying, I would get 6x squared times e to the 2x cubed, which would be answer choice A. Okay, in this problem, we have another chain rule problem. So once again, I'm going to start by designating u. So u is sine x, and then u prime, derivative of sine is just cosine of x. Now I'm going to rewrite h in terms of u, so it's going to be ln of u. And then I'm going to go ahead and take the derivative of h, so I'm going to get h prime, which is equal to 1 over u times u prime. So again, remember that the derivative of the natural log is just 1 over u. Okay, and now I'm going to go ahead and plug back in. So h prime equals 1 over sine of x times u prime, which is cosine of x. So I could rewrite this as cosine of x over sine of x. So this would be answer choice A. Just a simple note here. You could also simplify this further and you could just rewrite that as cotangent of x. Okay, so for number 4, we are going to have to use the product rule. Again, just note that we have two different functions being multiplied together. So in order to do this, to get p prime, we're going to do the first times the derivative of the second, which is just e to the x, plus the second times the derivative of the first, which is secant squared x. If this is slightly challenging for you, what you can do is you can do this more step by step. I kind of just did this in my head and combined steps. So what that would look like is I would write f equals tangent of x, f prime equals secant of x, g equals e to the x, g prime equals e to the x. And then you would just plug it into the formula. So whatever way works for you. Okay, but either way, we would end up getting p prime here up at the top. And then from here, we're just going to go ahead and simplify this. So let's just just rewrite it with e to the x in front. So it's nice and pretty. So there we go. So it looks like this would be equivalent to answer choice A. However, we could also simplify this by factoring out our GCF of e to the x. So we could bring that out front and we would be left with this here, which is answer choice B. So the correct answer here would be C, which is both A and B. Okay, this question we have to recognize as a quotient rule question, right? Because we see a fraction here or we see division. So for this, we're going to do low d high minus high d low to start. Okay, so low is just basically a different way of saying our denominator. So that's x squared times d high, which is derivative of natural log of x, which is 1 over x, minus high, which is natural log of x, d low. So that's the derivative of the denominator, which is just 2x using the power rule. And then this is all going to be over low squared or our denominator squared, which is x squared squared. Now we're going to go ahead and just clean all of this up. So x squared times 1 over x is just x. And then here we're just going to rewrite this to 2x ln x. And then this would all be over x to the fourth. Now we can go ahead and simplify by basically taking an x out of the numerator. So that would look like this. So x times 1 minus 2 ln x over x to the fourth. Now we can simplify here. This is actually a really common mistake that my students make, is that they won't properly simplify, or else they just get confused on this step. So I really encourage them, if they do get confused there, I really encourage them to actually factor out the GCF and then simplify, because you can really only simplify if your terms are being multiplied. So this is going to cancel out and just become a 1. This is going to cancel out and become an x to the third. So our final cleaned up answer would be 1 minus 2 natural log x over x to the third. Okay, for question number 6, we have another chain rule problem. So we are going to let u equal sine x, and then u prime equals cosine x. Now we're going to rewrite f in terms of u. So we're going to get f equals e to the u. Then we're going to take the derivative of f, and we're going to get e to the u times u prime using the chain rule. Now we are going to plug everything back in. So this will become e to the sine x times cosine of x, which is answer choice C. Okay, so once again for this problem, we have a chain rule problem. We have a composite function here. So first things first, we're going to set u equal to secant x plus tangent x. Then we're going to go ahead and get u prime by taking the derivative of that. So the derivative of secant is secant x tangent x. And now the derivative of tangent is just secant squared x. I'm going to go ahead and factor out my GCF now. Mainly I know to do that from experience. I just think it's going to make simplifying later easier. So let's go ahead and take out the GCF of secant x, and then we're going to get tangent x plus secant x here. Okay, so now let's go ahead and rewrite y in terms of u. So we're going to get y equals natural log of u. And now let's go ahead and take the derivative of that to get 1 over u times u prime using the chain rule. Okay, now let's go ahead and plug back into y prime and simplify. So 1 over u is just secant x plus tangent x, and then we're going to multiply this by u prime, which is secant x times tangent x plus secant x. So here, because these are being multiplied, now we can go ahead and cancel out our denominator with that. And so now we just get 1 times secant x for our derivative. So y prime equals secant of x, which is answer choice A. Okay, now for number 8, this is actually going to be a combination of the product rule and the chain rule. So let's start with the product rule. We're going to do the first times the derivative of the second. Up to you if you want to write this out formally using u sub. I'm not going to. I'm going to kind of just do it in my head. So the derivative of e to the 3x would just be itself times the derivative of 3x, which is just 3. So again, I use the chain rule there. Feel free to write it out further. That's just me kind of being quick and just kind of skipping through that. Okay, and then we're going to do plus the second times the derivative of the first. And again, I just used the power rule there. Okay, and of course, this is f prime equals. Now, let's go ahead and just clean this up. So let's see, what do we want to do with this? Let's write it as 3x squared e to the 3x plus 2x e to the 3x. So we do have a GCF here of e to the 3x, so let's go ahead and factor that out. And then we would be left with 3x squared plus 2x, which would be answer choice B. Okay, so for number 9, we actually kind of have 2 levels of chain rule there, because not only do we have sine of u squared, but we also have it of 2x. So again, dealer's choice here if you want to do u equals and v equals to write it all out. I'm just going to do one level of the chain rule and see if that makes sense, see if you can follow along with it like that. So what I'm actually going to do is I'm going to let u equal sine of 2x. And then I'm going to go ahead and do u prime. So derivative of sine is cosine. And then I'm just going to remember to multiply by what's on the inside. So multiply that by 2. So again, I basically used the chain rule again there. I just didn't designate another variable, right? Because I could have said like v equals 2x, and then I could have done v prime equals 2. But as you get more comfortable with the chain rule, I don't really think that step is necessary. Okay, so now let's go ahead and just clean up u prime. So it's going to be 2 times cosine of 2x. All right, so now we have our u and our u prime. Now we're going to rewrite our function y in terms of u. So this would all be equal to u squared. So then y prime is just equal to 2u times u prime using the power rule and the chain rule. And now let's go ahead and just plug it back in. So we're going to get 2 times sine of 2x times 2 cosine of 2x. Now again, let's go ahead and just clean this up. We can do the 2 times 2 is 4, and then it's just sine of 2x times cosine of 2x, which is answer choice D. Okay, so for number 10, we're going to have a combination of the quotient and the chain rule. I am not going to write out the formal chain rule notation once again, because ideally, as you get more comfortable with it, you won't have to. So quotient rule, as a refresher, is low d high minus high d low over low squared. So low is the denominator, which is e to the x plus 1, times derivative of the numerator, which is going to be cosine of 2x times 2 using the chain rule, and then minus high, which is the numerator, so sine of 2x, minus derivative of denominator, which is just e to the x. And this is all going to be over low squared, so e to the x plus 1 squared. And of course, this is equal to w prime. Okay, now we just have to clean this mess up. So let's go ahead in our numerator and let's go ahead and rewrite this term first. So we're going to have 2 cosine of 2x times e to the x plus 1 minus sine of 2x times e to the x, and that's all over e to the x plus 1 squared. Now let's go ahead and look through our answer choices. I'm immediately eliminating those because the denominator is not correct. And then let's take a look at A and D. Let's see, it looks like it would be answer choice A. Only difference there is they just rewrote these terms in the other order, but of course that is equivalent. All right, let's go ahead and move on. Okay, so for number 11, we are going to have to use a combination of the product rule and the chain rule. So let's go ahead and start off. So let's start with the product rule. So we are going to do the first times the derivative of the second. This is going to require the chain rule, so I'm going to write it off to the side here. So I'm going to let my u equal x squared plus 1, which would make my u prime 2x. And then I'm just going to rewrite this as ln of u, and I'm going to take the derivative of that, which gives me 1 over u times u prime. Now I'm going to go ahead and plug back in, and I'm going to get 1 over x squared plus 1 times 2x, or 2x over x squared plus 1. I'm going to just kind of write a little line here just to keep that separated. So going back to the product rule, we have first times derivative of the second plus the second times the derivative of the first term, which just using the power rule there gives us 3x squared. Now we just have to go ahead and clean up and simplify this big mess we have. So for our first term, we would get x cubed times x squared. It gives us 2x to the fourth over x squared plus 1 plus 3x squared times natural log of the quantity of x squared plus 1. All right, last thing we could do here is we could factor out a GCF of x squared coming from this term and this term. So we would get x squared times 2x squared over x squared plus 1 plus 3 natural log of x squared plus 1. And that would, of course, all equal to f prime. Okay, for number 12, we again have a combination of a trig function and the chain rule. So for part A, we're just going to go ahead and calculate g prime. So we're going to let u equal 5x squared, and then we're going to get u prime equal to 10x. So now let's go ahead and take the derivative of the outer function tangent, which would just give us secant squared of u times u prime. Now let's go ahead and plug back in. We would get secant squared of 5x squared times 10x. Or just cleaning this up a little bit, we would get 10x times secant squared of 5x squared. And this would be your answer for part A. Now for part B, we need to evaluate g prime of 1. So in order to do that, we are going to just plug in 1 everywhere we see x. So 10 times 1 is just 10. And then 1 squared is just 1, and 5 times 1 is 5. So this would be our g prime of 1 value. All right, let's move on. Okay, so for number 13, we're going to tie everything together and see how it can apply to a tangent line problem. So I like to teach tangent line to my students more in an algebra way rather than necessarily using the calculus notation. So what that means is we are just going to use our simple point slope form, which is y minus y1 equals m times x minus x1. So in order to plug into this, of course, we have to have a point and also a slope. So we are already given our x coordinate here. So our x1 is equal to 0. So let's go ahead and find the y coordinate to start. So what would our y1 equal? Well, that would just be h of 0, which is e to the 0 squared. Of course, 0 squared is just 0, and any number to the 0 power, including e, just equals 1. So now we have our point, which is 0, 1. Now let's go ahead and find our slope. So in order to do that, we have to take the derivative. So h prime would equal, let's go ahead and use u sub here. So let's let u equal x squared, and u prime would equal 2x. The derivative of e to the x squared is just, or I'm sorry, I should say e to the u. The derivative of that is e to the u times u prime. And then plugging back in is e to the x squared times 2x or just cleaned up a little bit, 2x times e to the x squared. And this, remember, is our derivative, which represents the slope. So now we have to get the slope at the specific point x equals 0. So now if we went ahead and plugged in 0 here, h prime of 0 would equal 2 times 0 times e to the power of 0, which again is just 1, but that's really irrelevant because remember 0 times any number is just 0. So in this case, our slope, or our h prime of 0, which is the same as m, is also equal to 0. Now we have everything we need to go ahead and plug back into point slope form to get the tangent line. So this would give us y minus 1 equals 0 times x minus 0. So again, I just used that and I used that point. So let's go ahead and just clean that up a little bit. 0 times anything is 0. So we would get y minus 1 equals 0. And then just using simple algebra, adding the 1 over, we would get y equals 1. So this is actually our tangent line. Part B says use your results to approximate h of 0.1. So in this case, since y equals 1, our answer for the linear approximation for h of 0.1 is just 1. However, I'm going to go ahead and plug that into the tangent line just so that you can kind of see what that would look like. So again, going back to y minus 1 equals 0 times x minus 0. What we would do here, if we're looking at h of 0.1, this is our x value. And we're looking for our y value, right? We don't know our output value. So plugging that in, we would get y minus 1 equals 0 times 0.1 minus 0. And then let's go ahead and just simplify this. 0 times 0.1. All right, just filling that in. You guys already probably see where this is going. Y minus 1 equals 0. And then we would re-get y equals 1. All right, let's go ahead and move on. Okay, number 14 gives us p equals the natural log of the quantity of x squared plus e to the x. All right, so in order to do this, again, we are going to have to use the chain rule. All right, so let's go ahead and let u equals x squared plus e to the x. Let's go ahead and get u prime, which would give us 2x plus e to the x. All right, and then let's go ahead and rewrite p in terms of u. And then let's go ahead and take the derivative using the chain rule. So that would give me 1 over u times u prime. All right, and now let's go ahead and plug back in for u. We would get 1 over x squared plus e to the x times 2x plus e to the x. And then just cleaning that up and rewriting it up here, we would get 2x plus e to the x over x squared plus e to the x. And again, this would just be our p prime. Okay, now let's move on to part B. It says determine the slope of the graph at x equals 0. So of course you have to know that p prime represents the slope. So basically what we are looking for is we are looking for p prime of 0. So let's go ahead and plug a 0 in everywhere. For the first term, we would just get 2 times 0, which is 0. And then e to the 0, remember any number to the 0 power is 1. So that would just be 1 over x squared would just become 0 squared, which is 0. And again, e to the 0 is 1. All right, so then we have 1 over 1, which is just 1. So this would be the slope of the graph at x equals 0. Okay, in this question, we are going to have to use a combination of both the product rule and the quotient rule. So let's go ahead and jump right in. At the highest level, we're going to start with the quotient rule, which is low d high minus high d low over low squared. So low times the derivative of the numerator. I'm going to write that again off to the side here. So in order to get that, we're going to have to use the product rule. So we are going to do the first times the derivative of the second plus the second times the derivative of the first. So let's go ahead and plug that back in here. So we're going to get e to the x cosine x plus sine x times e to the x. All right, so we just did low d high minus high times the derivative of the denominator, which is just 1. And I should put parentheses there like so. And then this is all going to be over lo squared, or just x squared. All right, so now all we have to do is clean this up. So, and this would be r prime equals. All right, let's start off by just kind of distributing this x into everything. So we would get x times e to the x cosine x plus x e to the x sine x minus e to the x times sine x over x squared. All right, so you probably see in your numerator here that we have a GCF. So we have this e to the x in every term here. So let's go ahead and pull that out. I apologize. I don't know why that just took away some of my writing. So hopefully we can move on without that. So I would get e to the x times x cosine x plus x sine x minus sine x all over x squared. And this would all be equal to my r prime.